and Jeremy to organize everything, to get everything organized and get working and get the presentation going. So just something very briefly about myself. I met some of the guys earlier. My name is Frans Pienaar. I work for RS Clare. So we are a grease manufacturer in the UK, based in Liverpool. And then myself, I come from South Africa. You can hear I'm definitely not English. I've got a different accent than you guys. And I started out in the mining industry of South Africa, coal mines. From there, I moved on to a lubricants company, and I've been started as an industrial rep for them, selling various types of oils. Then somebody found out that I'm mechanically inclined because I've done a fitter and turner apprenticeship, qualified fitter and turner, and then they put me in as a service engineer for the mining industry. That was then doing a lot of selling into that. Later became a senior service engineer for them, which brought me to the UK, and then worked for the UK and for Germany, traveling into Scandinavian countries and Middle East, and as well as West Africa, servicing all sorts of machines where they lubricate the greases. And then about 6 years ago, I started with RS Clare, and about 4 years ago, I started in the rail industry. Very interesting industry, but it's a very heavy learning curve for me of everything. And yeah, that's what's bringing me tonight. Yeah, I'm going to give you a little bit of a talk. Like I said, the TDS. You know, what's a technical data sheet? I think all of you have seen a technical data sheet before. And I think a lot of you have wondered what's the data in the data sheet. So I just want to give you a little bit of that. We talk about the test that's running about data sheets, and then hopefully you walk away with a little bit more information about greases when you walk away here. To start off, a few points. Next slide, please. That's it. So the points we want to cover tonight is just the composition of a grease. To talk about the TDSs, we have to understand what is a grease. Then you get different TDSs. This is not a legal document. The TDS is not a legal document, so it can change from product to product. And also all the companies can change the format that they put it in or the information that they put in there. It's not a legal document. If you want a legal document, that will be a SDS, a safety data sheet. And then we're going to talk about the typical characteristics of a grease, the base oils of, or the base oil characteristics, and then the features and benefits. Next slide, please. So first thing is, what is a grease? I can go around, I can ask anybody, but that's going to take too long, so we'll just run through it. First, next slide, please. The first thing is the main component of a grease is a base oil. So a base oil is 65 to 95% of a grease is the base oil, and that can be from mineral oils, synthetic oils, or semi-synthetic oils. And later in the slide or in the presentation, we'll go a little bit deeper into this. So I'm not going to do too much further on this. The next slide, please. So the next part of a grease is then the additives. And additives can again be antioxidants to make the longevity of the grease better, corrosion inhibitors, metal deactivators. And a metal deactivator, for instance, you get sulfurs that react with copper or non-ferrous metals, so as to deactivate that chemical process that's going on. So there's various additives that go in there. EP and AW as well. EP is for extreme pressure, and AW is anti-wear additives that can go into additives. Tackifiers to make it adhere to the application where you're going to apply it. If I talk too fast, please tell me to slow down. I have a tendency to speak too fast. Next slide, please. So now we make it, oh, sorry, can I just go one back? So if you have these two units here, and you have a base oil and an additive, that is actually an oil. So an engine oil or a gear oil or hydraulic oil, this is more or less the package of what it will look like for one of those oils. So to make it a grease, we have to add something to keep all of this together to make it a grease. And that is called the thickener. So if you go to the next slide now. So that's a thickener, and you can have various types of thickeners. So I have two sponges here, and I'll demonstrate for you now why I have them here. In a later slide, we're going to talk a little bit more about thickness, what you get out of it. But just to give you an idea, thickness, you can sometimes compare it to a sponge. So you can look at these two sponges, they're totally different. The one is quite coarse and the one is fine. And that's the same with the thickener. The thickener can be the same coarseness or it can be very fine. And that depends on how much oil it can suck in or how much oil it gives out at a certain time, depending on temperature, pressures, and all of those types of things. And to demonstrate that, a bucket of water here. So if I put this into the bucket and I suck some water up here, you can see there's nothing basically dripping out, but when I press it, there's water coming out of it. That means that the water goes into it and then keeps the oil in. And then, of course, if I put it back there and I press it again, it sucks the water back into the sponge. So in a nutshell, that's how a grease works. So that's a thickener. But there's other properties to a thickener as well. So it's not just to keep it in there, but it's one of the main properties that you have is to keep all the oils and additives that you want into that product. But if you use this one, I'm not going to put this one in, but if you put this in, it might be a little bit more water or less water that's sucking, or you maybe have more. Let's try it. You have more water that's dripping out normally. So there's not much dripping out. But if I put pressure on it, you'll see it starts pressing out. All right, so remember also that dripping, you can have normal drip without any pressures in it. You can have also water or lubricant that's dripping out there. Any questions on that? Nothing yet.
Well, we have both those sponges at home. My wife uses it for various purposes.
All right. So that is what a thickener is. And like I say, you get soaps and you get non-soaps. And I'll discuss this a little bit later. So that's a grease. So this is a normal grease, the composition of a normal grease. But then you get one more additive that goes into it. Next slide, please. So the next slide, and I put it a little bit up because not all greases have solid lubricants in them. The solid lubricants can be graphite, molybdenum disulfide, can be PTFEs, it can be any other type of lubricant which is in a solid form. So usually grind it down to a very fine paste and then get into the lubricant. So, whoopsie, as an example, this for instance here, it's usually, if the color looks like that, it's usually either graphite or molybdenum disulfide that's in the grease. So it's an immediate color change to a grayish, blackish color. All right, and like I say, not all products have it in, and you can have anything from about 2 to 15%. You start getting more solids in there, then you'll also see that your base oils become less, and then you start pouring in a paste. So that will be a paste, and if I look at this product here is a paste. So this is a copper paste. There's a copper solid in there, and there's more copper solid in there as base oils. All right. So also that just for the guys. That's where I don't think you will see that. Right, and that's then what a grease is. And that's just understanding what is it. But these things, all of them can differ, and all of them have different properties. Now there's the old saying, and I heard it even this tonight, when people say a grease is a grease is a grease. Now, this is not true. You can see how many different things are there that can make up a grease. And that's why we have a TDS. And of course, that TDS then gives you the different data of what this product can do for you and what application is for. So next slide, please. And that's what we're going to talk about tonight then, the different data sheets. So this is the technical data sheets from our company. We've got two different ones, two different products. And that's just to show you that you can have anything on a data sheet. We don't have to put anything specific. It's related to the product that we have on there. The one on that side is is a rail product. It's ClearTech EcoCurve track site. And that's a product that we're currently supplying to Network Rail. And that's the product that we will use also in the whole of the presentation. We'll go through the data for that specific product. But it can be for any product. It's related to anything or any grease that's out there that you want to look at. And then this is just a backpack sprayer. So this is something that you use to apply lubricants to switch plates or maybe a switch blades or anything like that if you want to apply it to. Also, something that I just want you to remember is that you'll see there's an NLGI number 1.5 there at the top. just remember that, because we'll reference this a little bit later, why there's an NLGI 5 consistency in there. Next slide, please, Jimmy. So again, the first part that we're going to look at then is the typical characteristics. So we're going to talk about all of these units. Some of them is very quickly, other ones we will discuss a little bit in more detail. But these are the typical characteristics that you will see in a grease for the rail industry. When you talk about heavy industry for bearing greases, you might see other characteristics that they will list in this. Again, it's specific to the product, to the application, and it can be specific to the customer as well. So if a customer say, well, I want a specific type of test that you do, I want that listed in there, that can be put into there as well. So it's a very customizable document. and I have to say again, it's not a legal document. That's why people can make with it, basically with it. But the information that's in there, we try to use the information as accurate as possible, on the test of it. So the first one then, next slide, please. We're looking at the appearance and the color. So firstly, that's where the color comes in. There's another thing that I've heard before. As you heard, I've been in the lubricant game for quite a while. And you'll get to a customer, you want to talk to him about his oil, and they will say, we use a blue grease, and that blue grease is the best grease for this application. And you go, but what is the blue grease? And you go, I don't care. If you got a blue grease, I will use the blue grease. It's the wrongest thing that you can ever say. Because this blue that's in here, and here we got the green, we have a blue here, and we don't have the blue here. So let's go, this is a bluish greenish color. So if you have this grease, it might be a composition from a synthetic oil, and maybe the other one that you have is a mineral oil, and the two is not compatible with each other, so it doesn't work. The blue that you see is a dye that's in there. It's got nothing. There's no performance to it. There's nothing to it. It's only for identification. So you'll put a blue dye in. So maybe certain plants will have, we use a blue grease for these type of bearings, or we use a green one for that, whatever. But there's no performance to it. So if you get there and a guy says to you, well, we use a blue grease, it doesn't tell me anything. It just tells me that you have a dye in it. So we need more information on that. The same with the appearance. The greases can be, and we'll talk a little bit later about the consistency of grease, but it can be smooth, it can be fluid, it can be semi-fluid. There's variance. And there's no standard to what it has to be. It's all about the lab technician that's working on it, what he decides what the grease looks like. So if you open this and you say, well, this is a green grease and it looks quite smooth. That's what he says. It's up to that guy what it is. And I can send this around and you can have a look at these. Please don't put your finger in them. Please don't mess them, but you are welcome to send them around and have a look. This one here, that's the grease that we're talking about tonight. Okay. You can send those around. Next slide, and this is the thickener part that we spoke about earlier. So as you can see here, I've got a picture. This is a picture taken under a microscope, and it gives you all the strains of this thickener, how it is, how it's made. Now, different thickness, like I showed with the sponge, have different strains, and that gives you how like I said, the oil is kept inside, or that the oil is released. If you click on that thickener, open there for me, please. So this is just to give you a model. We have soaps and we have non-soap. It's not everything that's listed under here or types of thickness that you have. I'm just using examples under this to say you get a simple soap and then you get complex soaps you can use. And then you've got non-soaps like clays, calcium sulfite, sulfonates, polyureas, but there's many, many more that can be listed under these as well. Now, the main thing is, what does that mean to you? To you as a user, if you get there and a guy said to you, well, I have a very wet application, it's underwater or anything like that, then you have to use a thickener, or you choose a thickener that is resistant to water. For instance, a calcium or calcium complex is very good against water. Lithiums as well, but calcium's is better. Lithium greases is usually good with higher temperatures. So if you have higher temperatures, you can use those type of greases. Higher temperatures, again, you can maybe look at complex greases. If you look at aluminium complex greases, they adhere better to products, and they also have a thixotropic property. So I don't know if you know what thixotropic is. So that is when the product is under pressure, it will become liquid. And then when the pressure is released, it basically goes back to a more solid state. So that's thixotropic on the grease side. And then again, with the clays as well, clays is usually very good with no dropping points, they good with very high temperatures. And then on this side, what I have here is on the right side, is a compatibility test. So you can see there's various types of soaps that we can have. But the most important thing is not all of them play with each other. So all the red marks here is the greases are not compatible with other greases. So that's the other factor that you have to think about is you might pick a grease and then you have to think of what you are using currently. So if you have a grease that's not compatible, you have to clean the whole system out before you fill it with a new grease. And that's something that many people don't want to do that. But that small change of doing that can give you a hell of a lot of benefit and cost savings. So it is worth sometimes to do that extra work and clean it out. Also with the compatibilities, there's many of these charts that you will see on the internet, but not all of these charts agree with each other. They might have different things that they say. So the best will be is talk to supplier and say to supplier, can you please do a compatibility test on the two products that you have? And the reason also for that is, we'll touch on that when we talk about base oils, because the base oils have the same issue as well. So you might look at the thickener for compatibility, but then maybe your base oil is not compatible. So the best always is talk to your supplier to find out what is compatible with each other. Just press on the grease there, please. There you go. So that's on thickness. The grease that we have, for instance, and that's just something about our company, a lot of free advertising. Our company is one of the few companies that make thickness as well. Other companies will buy the thickness in, and then they will mix the whole oils. Our company, what makes us unique is we make our own thickness, and that gives us then our own IP on it. That's why we say it's a complex. That complex is designed for us to make it a more environmentally product, but there's also other properties in there, which is IP to the company. So, and that is unique to the product. It also makes it a little bit more difficult for other people to just copy it because it's our soap and we won't sell it. All right, next slide, please. So temperature range, this is something that's also important. When you talk about temperatures, that affect the grease and how the grease will react. We'll talk about viscosity later, how that's also affected, but this is the operating temperature. And these temperatures is achieved by looking at various types of products that's in this. So that's the additives, the thickener, the base oil, and then all of them mixed together, how do they react? So there's various tests that will be done in the lab, and then they will decide, all right, well, the operating temperature is -40 to 120 degrees C. So this is the gauge phase grease. So think to yourself, -40, we might not see -40 in the UK, but you'll definitely see -40 in Scandinavia. Yeah, and then 120, I hope there's no rails that goes to 120, but maybe you guys can tell me a little bit more about that. But when we hit 40 degrees C here in the UK in summer, the rails most probably is much higher than 40 degrees C. I hope they're not 120, but they most probably is very, very hot. So you need a grease that can operate under those temperatures.
What's rheology?
Rheology is a type of test that's done in the lab. And that looks at the relationship between the viscosity of the product and the temperature.
Oh,
so normally you can look at it and you say viscosity is directly related to temperature. When the temperature to go up, the viscosity comes down, and vice versa. So there's just a very detailed test that's done in the lab. I don't do those tests. I can't go too much deeper. But if you want know more, I can give you more information. Just let us know. Next slide, please. Work penetration. So earlier we mentioned NLGI 1.5. I said, please remember that figure right in the beginning. So that's the consistency of the grease. The most common grease that you all maybe are used to is a number 2 grease. And people will come and they say, well, we use a number 2 grease or 2 consistency grease. Motor bearings maybe sometimes a number 3 grease. How that is done is, so work penetration, you have a cone that is hang from a certain height, and you can measure then how far that cone drops down. And inside you have a prepared sample of grease, and that what it means by work is you have a perforated plate, and that plate is a certain, I can't remember how many times it's worked then, and the grease is then worked to a certain time. Then that cone is dropped into the grease, and then it's measured how far it dropped into the grease, and that then gives you the NLGI number, that one there. And then we come to the chart that I have here. So you have an NLGI number, anything from a 000 to a 6. 000 is a fluid, as it says here, and a 6 is a hard compound. So I don't know, do anybody know stick lubrication that you see on rolling stock wheels? So only get a stick up, I'm actually a sample with. So you get stick lubrication, and that can be a number 6. So it's a solid state. It's not a fluid or semi-fluid or anything like that. Right, and that one, for instance, if I look at it, so it's between a 2 and a 1. There's not an official 1.5, but we call it a 1.5 because that's what the workbench is. So that's the consistency of the grease, and that's important to you guys. And if you want to, pump something, pump greases, or if you want to have it to flow maybe in the application, or it has to stay in the application, that is important for you to decide on why it's there.
So what are these ones?
Oh, they're good. So this is the 1.5. So you can still say it still looks quite stiff. It won't just flow. And those ones is most probably also 2s and 1s. Unfortunately, I don't have a fluid one here, but that is just a very you can almost say like a honey type of flow that it can have. All right, and then next slide, please. So then we have a draw point. So draw point is also temperature related, and what that means is they again have a cone. The grease go into the cone, and as when the grease go from a solid or from a semi-fluid to a fluid when it starts flowing out of this container. So that is 170 degrees C for this specific product. It's not the upper limit of the product. That's when the product starts flowing out of the application. So the upper limit, we would say, is about 20 degrees less than what that draw point is. At the bottom here, or in this side, I have a few slides or a table that show you different thickness, and then also their draw points, and the temperatures what it is. But the main thing that you have to remember this is only related to the thickness, but there's other components in there as well. There's base oils in there, and there's additives in, and all of those can change also how that product is going to react to it. So this chart is only as an indication. It just gives you a little bit of idea, again, to pick what type of thickener you maybe want to use. Next slide, please. This is a big point, it's oil separation. Now, oil separation, if you think about the sponge, it's also called oil bleed. When you have the oil in it and the grease is standing for quite a time, you can then have the grease comes out of it. And just one on. So this is a photo of a container, or actually a tank. And you can see on the corners here, there's a little bit of oil that's in there. Next slide, please. This is an enlargement of what you see here. So there is a little bit of oil that's here, and that's called oil bleed or oil separation. So the oil is coming out of the grease, which is a normal effect. There's nothing wrong with it. Usually you want to see less than 5% of oil bleed. Now, if this is a tank of 50 kilogram, if you see something like a kettle full of oil in there, 2.5 liters, then it's a worry. Anything less than that is not a worry. It is normal. You can see it. And that test is then also used to give an indication of what will happen in the storage of the product, because it's done under higher temperature than normal, and also for a certain period of time. So this is 40 degrees C at 168.
If you stir it up, is it all right?
Yeah. So if
go back in.
Yeah, if you're like this, if you have it like that, if you just have a clean piece of equipment or pipe, spatula, anything, you can stir it up and it will go back into the unit. So it's just applying a little bit of pressure and it go back. Nothing wrong with it. But like I say, a lot of people worry. They start seeing a little bit of oil there and they go, oh, there's a problem with the grease. If you look at, also think about the beginning when I say there's about 65% to 95% of base oil in there. So your main component is base oil. So the amount that have to come out to be a worry is a hell of a lot of oil. But we say about 2.5 liters on 50 kilogram. So that's about a kettle, a little bit more than a kettle full of oil. So yeah, this product is just stated as minus or less than 5%, which is good. Next slide. Right, these tests now. So just one more. Okay, so this is a 4-ball scar, wear scar test, and this is done to see what is the long-term effect of the grease on the application. And it's a very simple test that they do. These balls are for the next test, but the same equipment is used for this. So you have three balls here that you have. Those balls are fixed at the bottom of the machine, and then you have another ball, a fourth ball on the top side, which then get placed on top of it, and that ball can rotate. For this specific test, it rotates about 1,440 RPM. And then a force of 40 kilogram is added on top of this top bearing that's going to spin around. So you put everything in, you lock it in, you put grease in there, and then you put the ball in, and you let it run for an hour. So when you run in for the hour, after the hour, you take it out, and you measure the wear scar that's formed on the balls. So you do the test 3 times, measure it again, and that gives you the wear scar. So that gives an indication on how the grease will perform over a long period of time. This specific grease gives you a wear scar of 0.5 millimeters. The dry test is about 1.65 millimeters. So it's quite a difference in the wear scar that you get from a dry to the lubricant. Anything under 6, is usually in the rail industry would be a good measurement. In different or in other applications, like bearings, it might be that you need a grease with a much lower value than that, and 0.5. And that will be then all about the additives that you add into the grease. You can go to the next one, and then I'm going to send these around. Only thing is, when I send this around, maybe just show the guys also at home. So this is a 4-ball test, and then I'll send this around, but just be careful. With the welding, it does leave some sharp edges. Please don't cut yourself. So just be careful how you handle it. And there might be some grease also stuck on them.
So this is seized together.
Those are seized. This is the next test. So one more slide, please. So that's the seized. So this test, that the ones that seize together, that is the 4-ball weld load test. So this is the test that we're talking about now. But like I say, it's the same equipment that used for the 2 tests. It's just different methods of doing it. So with the weld test, you have these balls. Again, the balls at the bottom is fixed, and they have a ball at the top that get a load applied to it. But this ball will now turn about anything between 1,450 to 1,500 RPM will be the speed of the ball, the top ball turning. And this time it's only due for 10 seconds. So you apply greases to it. The ball turns. You put it down onto the bottom balls, and you spin it for 10 seconds. If it's not welded together, you take everything apart, you clean it off, you put new balls in, and you load a next load onto it. So then you increase the load. And that load can start anything from 6 kilogram, and it can go up to 800 kilogram of load that you can put onto that machine.
Where's the actual measurement then that you're talking about, that 5?
So there's a lever on the side that you put weights onto that, and that calculates the amount of weight that you put. So it's kilogram force that you put onto the ball, and that will be related to the lower ball. Answer your question?
Yeah. How is it spun?
There's a motor on top that it spins through. And that motor, like I said, you can do speed control on it because you can test at various speeds. You don't have to test at a specific speed. Depends on what test you do and which institution you use, which test method you want to use. So there's different tests that you can do. If you have a load, this is for instance 400 kilogram for rail, that is fine. The specific tests relate to instant on railways for the gaugeways. It's instant shock loads on the rail between the rail flange or the wheel flange and the rail. So any shock loads, that is what this grease will show, that you have a EP additive or a EP protection between the flange and the rail. So any of those shock loads will then be protected. If you have a load that's higher than 800, and we have greases that is higher than 800 load, you can't go higher than that. There's no classification for it. It stops at 800, and then it's just classed as plus 800 kilogram force. That's in that one. Also, you can get companies that will give you the data in Newton. So if it's in Newton, it's just 9.81, but most people just times it by 10 or divide to get back. That's just the normal. Right, next one. The next is the import test. So on the railways, and we're living in the UK, so there's a lot of rain. We need to do corrosion testing. Why on rail? You have metal-to-metal contact. So when you have metal-to-metal contact, it's quite shiny, and that shiny attract corrosion, like nothing else. And you need to protect that layer that you have. And that is then done with the grease. So you test the grease to see if it can give you a corrosion protection. This test is a bearing test, but it's the best test that we have to do corrosion test at this stage. So what you will have is you will have the bearings. There will be a bearing inner race here, and you fill it with grease, and then the bearing is half filled with either distilled water or a semi-synthetic sea water or a solution of sodium, I think sodium chloride. There's other products that that's usually the three common ones that you use. This specific product has been tested with distilled water. It's classified as distilled water. So you put it in, and then it runs for a certain amount of time. And actually, I forgot to check what's the time, how long it runs. But it runs at a certain temperature, a certain amount of time that it runs in there. It's then taken out, and then the outer race get inspected. Now you can go to this one here. It gives you all the classifications, anything from a 0 to a 5. And that's what you will see then said there, a 0 to a 5. This is a 0, and this is a 0. So if you look at the inner race on where the balls, it's a double roller bearing. So if you look at the inside on the race where the ball bearings will run, there is basically, or there is none corrosion on this one. So this one is good. It's a 0. But I'll send this around as well. The next one, this is a 1. And you can see how fine it is. There's one mark on the race which shows you there's corrosion. And I'll show the guys here. There's a small little mark there, and that then makes it a 1. The guys as well. I'll send this that way. Then the last one, if I show you the guys here again, that whole race is, you see it there? Not really, but the whole race inside is full of corrosion. So that makes this specific one then a 5. So that's severe. And that's how the test is looking. Like I said, it's a bearing test, but it is well worth doing to see how the grease is going to perform against rust on the road as well.
Looks all right.
All right, next one. Oh, I see we're going to finish very early. I got a tendency to talk too fast. So we have copper corrosion. That's another interesting test. Why would we want to do copper corrosion? It's out on the rail, nobody worried about it. But how many cables are there not in the railway or around the railway tracks? And copper corrosion can cause shorts and all sorts of problems that you can have on the railway. So this test basically look at it, and we supply London Underground, and that is one of the things that they look at because they had issues in the past with copper corrosion. So how it works, just one please. So how it works is you take one of these plates, so just the guys there, take one of these plates, and then you put it inside of a container, and you fill it with 30 milliliters of lubricant that's on top of it, and you leave it in there for 3 hours. I think it's 100, let me just make sure about it. You leave it in there for 3 hours. Yeah. Yeah, so leave it in for 3 hours. This specific one is at a higher temperature, but for a shorter or for a longer period of time as well. So we actually went a little bit further to see how it's going to react. Then after you have it in there, you take it out, you clean the grease off, and you compare it to this chart that you have here. I couldn't bring one with because it's like a plastic unit, and they have these colors on there, and it's covered with all sorts of things, so it doesn't discolor. And they didn't want to give it to me. Maybe they
This copper corrosion,
that's this copper corrosion.
it's nothing to do with return currents in DC third rail systems, fourth rail systems, anything like that.
No, but it can affect maybe the cables that's on those type of things, but not on the rail itself.
So no connection between the electrical current and what's going on in the grease.
No.
Can it suppress bimetallic corrosion if you have two dissimilar metals close together? Is that a purpose of it as well?
I have to be honest, I don't know.
No. Right.
We can talk about it later. I don't know what you.
Electrolytic corrosion.
Yeah, that's right. Yeah.
But we can discuss that, and I can give you an answer. All right. So just back to this thing. If you look at this, you compare to one of those. Okay, this specific grease is a 1A, so it means that there's no sign of any tarnish or any corrosion that's formed when you use that grease. This is a different grease, different plate. So I'll just show it to these guys as well. The difference between the two.
Yeah.
And then if you hold it here, so this is about a 2C that you have on that specific plate. I'll just send these around as well. You can have a look at those. But like I said, the importance for this is when you have lubricants that's working close to any electrical cables or any copper for that. You get, for instance, gearboxes that have brass or non-ferrous metals inside, and you have to be careful when you use that because it's usually the sulfur that reacts to the metal, and that causes this type of corrosion. So you have to be careful of what's in there, and it gives you a good idea then also copper corrosion is any protection. Also, the base oil that you use, it can also have it's a good thing to check in the base oil because the better the base oil becomes, the less chance you have of this copper corrosion. Yes, sir.
24 hours seems a very short time to get corrosion like that.
Well, you can see that the temperature that's increased, so that actually accelerates the process.
We talk about cables that will be there for 5 years or more.
Yeah. But sometimes it does. Like I say, with the London Underground, they found over a period of time that they had problems, and this is something that they then start putting into place. That they look at. You won't have grease falling onto cables just for nothing, but you can. It is a possibility on the railway that you can have it. All right, next one. So again, we live in the UK, so water washout. You can go one more, please. Look at water washout. If you take a bearing, the full bearing, you have a water that's sprayed with certain pressure, certain temperature onto the bearing, and you want to see how much grease is then removed off the out of the bearing. So 6% is good. Anything smaller than 6%, this is a 4%, which is fine. We're happy with that. But what does that mean for the rail industry? Again, the same thing. These tracks are out on the in the environment. There's rain, there's storms, there's all sorts that's taking place there, and that events that the grease is not washed off, and you have any issues on the rail that you have the dry rails out there. So again, it's just an indication for you of how well will it perform in water environments. Some greases, if it's very bad, you might have a very short carry down because it is washed off, and we'll talk about carry down. Talk about that now. Next one, please. So biodegradability. This is a heavy side of it, and I'm not going to go deep into this. This is one of the parts where we can honestly do another session. If you're interested in environmental friendliness, which is a big subject lately, and I think it's an important subject to know something about. But there's so many complexity around this whole thing. As you can see, this specific one, We test at an OECD 301. That's what we test at. But we test at B. So B is the specific test here. That's the result. But there's 5 other ones as well. Now, just to read something for you, this is something that I got from it. It says method 301A. So it's the same method of testing 301A. We say method 301A is similar to the ISO standard 7827 1984, and replaced it the modified AFNOR method. So that's a different method that this replaced. But then the AFNOR has adapted ISO standards. And then method 301B, 301D, bottom one, and then 301E, is that one there, is modified version of earlier OECD guidelines adopted in 1991. Method 301C is similar, identical with earlier guideline 301C MITI 1. Method 301F is very similar to 301C. So there's so many ups and downs on what this is. And that's why I say, if we're going to sit here, we're going to sit here till tonight to try to figure out what all that means. And to just put something extra into that, this is the way that we test it. This is internationally accepted, but there's a different method that other companies test with, and that is CEC L33T from 82. So that's something that you will see on some TDSs as well. That test is specific to evaluate the bacterial biodegradation of 2-stroke engine oils. So you have to decide, is that relevant to what you want to do? And that's what all of this also means. Is it relevant to what you... Environmental friendliness is very important, but does it mean what you want it to mean? And I think it's something that we can definitely go deeper in. The presentation, there's many slides after that also about environmental friendliness, but I think it's not for this today. So if you're interested, please let Richard or Jeremy know, and we can put something together and we can do environmentally friendly presentation for you. Everybody happy with that? All right, then the next part. So we go on to base oils. Just click on the base oil at the top there. So again, you get different base oils. I said in the beginning, if you remember right in the beginning, we said base oils is 65 to 95% the composition of base oil in the grease. Now, base oils can either be synthetic, it can either be semi-synthetic, or it can be from mineral oils. So the API divided base oils into 5 groups. So the first group, and I will call that a basic mineral oil, is refined in a refinery, and that's the oil you get, usually like a brownish color, and it's a simple base oil. Then you get group 2 oils, which is hydrotreated. So what they mean by hydrotreated is there's certain chemical processes or certain processes that's been done in the refining process that makes the oil cleaner and then improves the properties of the lubricant. Then the group 3 lubricants is hydrocracked. So that's just a further process with higher temperatures and higher pressures that's applied to the group 2 products that makes it even cleaner. Now that's a mineral oil, but many of those base oils can be classified as a synthetic oil. That's how clean they are after the hydrocracked process. Then you get group 4 products, which is full synthetic products, and they are called polyalpha olefins. They are chemically created in a factory. They're not coming from mineral oils, and that is used all over the world. It's definitely a growing market in those type of base oils, and you will hear PAOs is commonly spoke of as polyalpha olefins. That's fully synthetic lubricants. They're also quite the group 4 ones. They're very compatible with some of the mineral oils as well. They mix. They call it. They play well with that. Then you have the group 5 or the group 5 base oils, which is all the base oils that you do not find in group 1 to 4. Now that can be fully synthetic oils or semi-synthetic oils. And what I mean by that is, so fully synthetic oils is your synthetic esters, synthetic silicon oils. You can have your polyalkyl glycols that falls into that group, PAGs. But then also you can have a mixture of synthetics and semi-synthetics that comes. So anything that's not classed here on its own, that's in there, is a class 4. Now, all these products have different properties that you're going to look at. You know, the temperature and what they work. Many people prefer the PAOs because they're very good at high temperatures. And the same also with some of the other esters and the polyalkyl glycols. They got properties that you want to use. And it's good if you want to do a change in a lubricant, or you have maybe an issue with lubrication or bearings that keep on failing or anything like that. It's worth to look at these type of things. What is the property of the product that you currently, or the lubricant that you're currently using? And is there anything else that you can maybe use to improve it? And it can be improved. You can reduce your failure rates if you just change the base oil of the product. Right, again, we spoke about it with the thickness. This is also downloaded from the internet. It's just a compatibility chart about the different base oils that you get. Again, so you can say, well, they're not playing together, or you can say, well, they're compatible, but they might be compatible here, but the thickness might not be compatible. So that's why we say always speak to your supplier and do a compatibility test. Or you can use an independent laboratory as well to do a compatibility test to make sure that the products that you're going to use is compatible. Click on the grease, please. All right, so that is about the types of base oils that you get. The next part of it is viscosity. Now, viscosity is the resistance of a fluid to flow. And this is what I want to demonstrate with you with these. Yeah, I've got two different oils. They actually very good also to show you that they might be both clear, but they are two different oils, two different types as well. The base oils is from two different base oils. This one I think is an ester, and I don't know what this one is. But this oil here at 40 degrees C, it is 45 centistokes at 40 degrees C. So currently we're not at 40, we most probably sitting at 20, let's call it 20. So it might be 50, it might be 60, I don't know what it is at this stage. The oil on this side is 5,000 centistokes. Centistokes is the measurement of viscosity. So that's square millimeters per second is the value for that. Now, this is a much thicker oil, or less resistant. And what I'm going to do is I'm going to flip these two around, and we're going to see how fast the balls at the bottom. You can see there's a ball at the bottom at both of them. We're going to see how fast the balls will go to the bottom side again. The other part of this also is you'll see there's an air bubble at the top. At both of them is an air bubble. So how long will it take the air bubble to change to the other side? And that's the resistance to flow that we're going to check with this. If I flip them over, this one's already done, and this one is still flowing. And that gives you the resistance to flow. This is a much higher viscosity product. But what does that mean to you? Why do you want to know what's the viscosity? So if you think about pumping a lubricant, which one will pump the easiest? Definitely this one. Because it flows much easier. This one is definitely taking much longer. Now, just for interest sake, the product that I work with the highest viscosity ability was 30,000 centistokes. This is 5,000. The 30,000 one, if it's not been heated, it can't be pumped. You can't do anything with it. It's a nightmare. But yeah, very good lubricant base on the application. All right, any questions on viscosity?
So what is that dimension?
It's millimeters squared per second.
Didn't do that in physics at school.
No, definitely not.
No trouble early.
All right, the next one is then flash point. So flash point is, if you look at the flash point is the temperature at which the vapor that comes off the base oil will ignite when it's exposed to an ignition source or explode. So vapors, when it comes, it's oils, the vapors coming off. So if you're working in confined spaces, things like that, it depends on how much oil there is, how much lubricants. It is something to be aware of.
But no greases that are self-combusting at a certain temperature. Self-combusting.
Self-combusting.
There are some.
Yeah. This will self-combust at 220 degrees C. So if it's not self-combust. This is when it's to the ignition source. I'm not sure about self-combusting. However, if you look at diesel will combust at pressure.
Yes.
So there is products depending on the pressure. Yes. So pressure can make the combustion. Yes. So it is self-combustion with different pressures. So yes, so that is important, to know when a product will combust. Then the next one is pour point. So pour point is if I take this and we say it's a beaker, and I hold the beaker, and as soon as that product stops dripping down, that's the pour point. So that's the lowest temperature that the product can go to before it stops pouring down. Now again, it's a QC test that they do, and something interesting is that you can see this pour point from this product is -30, but the operating temperature was -40. So that's quite different. So that means all the things that we mix together, this is only based on the base oil. This is the base oil data that we're giving here. But when you have the thickness and the additives and everything together, that can change your temperature range that you're working at as well.
Surely there isn't a sudden cut-off at pour point. There's going to be a transition period in which the rate of flow gets slower and slower and slower.
Yeah, but when it stops dripping.
But how do you define what stop amounts to? I mean, it could be asymptotic.
We must ask the lab for that. I just give you this information. How they do it is up to them. But they say a beaker, they take a beaker, and when it stops dripping out, that's when they classify that.
Mhm.
And believe me, most of these tests is scientifically. There's you can see there's IP34, so that means there's an IP34 test that's been done to do the flash point, or IP15 to do the pour point. There's a method and certain materials or equipment that needs to be used to do these tests.
I mean, I would expect the pour point to be defined as something like, say, the temperature at which the flow becomes less than, say, 1% of the mid temperature range flow. You've got a curve, and so you arbitrarily define a point on the curve as your cutoff because it doesn't exist naturally. It's not a digital function, is it?
No, I agree. But the main thing is that the way that the test is then defined is they look at when they decide that that's the point that it's going to stop,
Right.
and that will be the point where it stops dripping out of the beaker.
Right.
So it stops flowing. That's the point when they say it's now pour point. And then the bottom one just is a USA environmental acceptance lubricant, and that's just a test again for the USA to say that it won't kill anything in the aquatic environment. So it's, again, it links back to the environmental friendliness for lubricants. All right, and that's why we use then the specific base oil, because it's a environmentally friendly product. And this specific product is eco-labeled. Again, it's a part of the environmentally friendly part that we can do later on. And eco-label is the highest classification of biodegradability that you can currently get in Europe. All right, next one. This is the last slide that we're going to discuss. And this is features and benefits. And I only highlighted one piece here, and we're looking at carry down. So carry down is a term that's used with gauge phase lubricants on the rail. The wheel picks up the lubricant on an applicator, and then it goes down the rail, and basically the wheel puts down the lubricant. And then carry down is how far this lubricant is measured or seen, rather say seen down the line. There's no scientific test to determine what that distance is. It's a very big topic currently going on, but there is no test. So these type of things that you will see in features and benefits is properties that's seen in the field. So it's maybe not done in a laboratory, but you see in the field how the lubricant reacts, and then that is what's been that can be put in here. So again, it's not a legal document. It's used as a technical document or technical sales document. And then when people put it in here, they're going to put things in here that's relevant to the product and relevant to the customer to make or help the sale, or to explain to the customer what the product can do for them. Right, there's various other things that also can come in here. So what I can say about features and benefits is usually anything that you can't test in a lab that goes into this, that's maybe been seen in field trials or field operations, or over a period of time had been observed how the product is working in the application. Next one. And that's it. We're done. So from my side, I hope it was informative to you guys. Any questions? I'm open to take any questions. If I don't have the answer, I'll get back. We can discuss it and I can get back to you guys. Here's my number and my email address. You're welcome to contact me or anybody if you want to know more about lubricants. This was just a little drip in the bucket.
Does Network Rail have a standard for rail lubricant or oil in transformers or in oil field cables? Is there a standard which is given to yourselves that's normal or
the easy answer? The easy answer is Network Rail have standards for everything that's used on the infrastructure.
Yeah.
So anything that's used have a standard. Lubricants as well. There's a standard that we have to comply to, and then we manufacture according to that. Or we might have something better, and then we will do a trial with them. So we will get a trial application form, and we'll do a trial with Network Rail then to get the product approved on the network. You can't use products on Network Rail if it's not been approved by them.
Okay.
And then they have to comply to the standard that's there or a newly created standard.
Do they just have one standard? I mean, for example, if we're down a coast along seaside or something like that, maybe the rail lubricant might be effective in some way with salt and spray.
With the greases, no, there isn't. You know, there's one standard that they're working, with the lubricants. With other products, there might be standards for down at the coast and inland and things like that. I'm not aware of those, but with the greases, no, there isn't. It's one works for all.
If one's on the railway, is one going to be baffled with a wide range of lubricants to choose from, or is it a fairly limited list? Any guidance, any ideas?
Oh, that's a very good question.
We had the point just then about, of course, different sea,
Yes.
inland or seaside, which is one, but could there be a load of other issues?
Very. There can be many other issues that you want to
It's
look
quite
at.
a specialist thing to
Oh, yeah.
select which grease to use for something,
Yes.
right?
And that's why, to give you an idea tonight, is to give you a flavor. And just to get back to what we spoke about right in the beginning, there's so many people that think that grease is a grease is a grease. And I can use this grease in my bearings of the car, or I can use this grease in whatever. But if it's not designed for that, or it maybe have not the right base oils in it, you're going to cause more damage than good. And that's why it's important to know. And here we're sitting with six tubs. These 6 greases are all different. They've got different properties, different applications. And if you use the wrong one in the wrong place, you can cause more harm than anything. So yes, to answer your question, to pick a grease is a very specialized thing. Oils is, I don't want to say oils is easy because oils are also very complex. But as soon as you put the thickener in, everything changes. Also, the way that you manufacture the a grease, you can think of a cooking recipe. I think I put it in a synopsis there. Is you can put a cooking recipe. If you bake a cake, there's different components that you put in. And with a grease, you put different components in, but you put it in at different times, different temperatures. And when it's in, you might lower or might increase the temperature. You might do different things before you decide this is the final product to have in there. And that's why a grease from one company to another company can differ so much more. And they can say to you, well, the base oil in this one is a lithium complex. The base oil in this one is a lithium complex. The thickener, the thickness is lithium complexes, and the base oil is esters. But it's not to say it's the same grease. There can be something totally different in it. And that's very important to talk. Even for myself, if I go to a place and I want a grease for beering, I'll stand for hours to decide what I want to use, because maybe sometimes we overthink things. the Thames.
No, I've got two questions, but one of them is in two parts.
There's big questions.
The first question is really what happens as a grease ages? And the part one and the part two are A, in its container, i.e. in storage, and B, in service. And are they different?
Good question. So we refer to the one test there where we have the separation. So under storage in a container, you can have that it can bleed out, so you can have a lot of bleed. You have products, for instance, especially if you look at new type of products with PTFEs or polymers in there. What happens is the bleeding out of the product is so quickly that the shelf life is only 6 months. So that's very, very short.
There's a big variation among.
Yes. Shelf life for this product, for instance, is 3 years, 2 years. But after 2 years, we say, if you have a big batch of the same lubricants, send them and we can test them and see what is the use or if it's still possible to use it. So that's the one side, you can have bleed out of it. The other side is also some of the additives can age in the process as well. So you need to know those type of things as well, that additives
To
can.
the extent that it's no longer functioning as a lubricant.
Exactly. So that's why it's very important when you have a grease and you look at the shelf life, that you didn't exceed the shelf life. So if there's no shelf life on it, get the batch number, phone the supplier and find out what's the shelf life if it's still active to be used. It is important. It's just like food. There's stuff in there that's not usable anymore. And then your second part is in use. So additives can be used up. So when they're in motion, EP additives, those type of things, it is I think my technical team will kill me if I say this now, but let's take it as it's an active component that's helping to reduce wear, but it can be used up. So you can complete it and then
consumable, basically.
Yeah, and then it's not usable anymore. And of course, then you can have oxidation. As soon as anything get in contact with air, it starts aging, and that's why we have anti-oxidation additives that goes into lubricants as well. So there's a lot of things. Yes, you can. And your answer to that is what will happen. What it will do, it will change the color. Can change because oxidation will change the color as well. And then you can have the grease can go stiffer. It can go, maybe slumpier. So there's various things, but the grease can change totally. And when it starts changing, it does affect the application.
And the other question, unrelated, or sort of, what do you do if you don't know what kind of grease you're dealing with? You've just been asked to apply more grease to somewhere that's already got some grease on it. You don't know what sort it is. And I noticed a lot of your slides about compatibility. But how do you know if you're making things better or making things worse?
Does it break early or does it break later?
What do you do in those circumstances?
It's a very good question. So I think that's one of the biggest problems that there maybe is in the industry is you get a maintenance team together, and there's no disrespect to anybody, but sometimes that you see is that the guy that's going to apply the lubricant is not the person that's maybe the highest qualified in the team, because it's seen as a low class job, and I disagree strongly with that.
In a grease monkey.
I didn't say that. So I didn't say that, but that's the problem, and people need to be educated on these greases or what to use where, and that's where the problem comes in. If you have different greases used, people go put it on the wrong places, and that's why you have the colors where people maybe want to distinguish it between colors. You use these colors for those bearings, you use these colors for those, because that's the easy way to distinguish what you're going to use.
Do those colors last?
Pardon?
Do those colors last?
Yes, it's a dye. It's a permanent dye that's in there. Except if the grease starts aging, the color can change as well.
Oh, that's the point. Yeah.
But the point is, if you have somebody that don't know what's in there, you have actually a problem, because that's a bad part of maintenance. You have to have a register of what your oils are in what products. That will be good practice, to have a list like that.
So you just degrease half a mile of check rail and start again.
Exactly. Yes. you have to, in network rail, they have two different greases that they use for gauge phase lubrication. The two greases is fairly compatible with each other. So they just interchange it, but it's not the best practice to do. The best practice will be to clean it up. So to answer a little bit further on your question, if you're not sure about it, clean it up and refill it with new grease. Because that might be a cheaper option than to just fill it with any grease, because that can cause a failure and untimely failure.
So if there are two, sorry to just follow on that point.
Yeah.
If Network Rail have two types, why have they got two types rather than just the one?
They don't want one supplier, and two suppliers will never have the same grease. So that's what they're looking at. So when the tender went out, we and another company won the tender, and then the people in Network Rail can choose which one they're going to use. There's no specification to you have to use that or you have to use that. It's all in onto the user of which product they prefer to use.
Okay, thank you. Good.
Jason, are any of your greases made from animal or vegetable byproducts, which might be seen as environmentally friendly, for example?
I have to answer the question. Why do you want to know?
Well, it's just wondering because, I work for the Environment Agency, a lot of them have grease all over the place and near the rivers, and first question they ask is it harmful to marine life? And the perception is if it's come from an animal or vegetable, then perhaps it's slightly better than if it's a mineral product.
Okay, very good question. The reason why I'm just asking because there's so many, there's a trick question in there, but yes, the products that we have, many of them might come from vegetable oils, vegetable extras, and that makes them biodegradable and better oil to use environmentally. This product, for instance, like I said, is a eco-label product. It's the highest level of biodegradability that we can get classed with Europe, and that makes it also non-toxic to water ingress, to rivers and everything like that. And that's one of the big reasons why Network Rail prefer to use, or not prefer, but use this grease because of it.
Or from recycled rail ministers? That'd be very corrosive, wouldn't it?
Yes.
So I'm thinking like lock gates, for example, we have masses of black gooey grease on the rack and pinion, and it has to be, that's very particular. So, because it goes straight in the water all the time. It has to be,
But you can, applications like that, it's always, it's worth to look at the application itself, what you have. So you first have to look at what properties you need, and then you can work it back to what is then environmentally friendly product to use. But yes, animal fats and
vegetable oil.
Yeah, vegetable oils is definitely used.
Oh, okay.
Yes, sir.
If with your experiments you came across a recipe that gave you the same profit margin at half the price, would you tell us?
No, I wouldn't want to do that. It's a bit of a business. To be honest with you, I see where you're going towards. But what happens is when they design a lubricant, and we went through a whole design thing now on top of rail friction modifiers that we're launching. So the whole process is you always want to go is the chemists that work with it forget about the cost. They don't think about it. They think about the application, and they think about what's the best for the application, how to make the application work best. So then they design the whole product, and then they have selections and see how they do to bring the cost. If the cost is sky high, they would try to bring it down. But at the end of the day, the price is basically linked to what the cost is of the product to manufacture. So we have to make a profit margin to do that. When the product is made, you will not easily get that. We will change the product, because if we get a product approval, for instance, with Network Rail, we can't change that product because that product is then stacked. That's what it is. If we change anything in it, we have to do the whole approval process again from start. So to answer your question, then we can't change when the product is already in there, but it's in the design. We look at the cost, and then we determine what the price is at there. But yeah, it's not to manufacture these type of things. Any other questions? Yeah, yes.
Yeah, I've got in the garage, I got a tin of grease about pint. It's called BP Energrease. It's sort of greeny yellow colour, and it's got the same sort of consistency, smells the same as when I bought it. And I just use it for occasionally go bulk you and it's really stiff, so you put a bit of grease on, put it back in. And it still seems to be exactly the same as when I bought it in about 1962. 62? Yes, 62. Well, I'm giving away my age now. Yeah, but it doesn't seem to have changed a bit. Will it have changed actually perceptibly?
I think
Because for general purpose.
No.
Automobile.
By all means, that grease is most probably made from a mineral oil. So if it's from a mineral oil, there is changes that can take place in the base oil. So to answer your question, I think there is changes that can take place. If you use it, for instance, for wheel bearings, you might get a different effect than just using it for bolts. Because using it in a mold, it's not a heavy application. But if you start looking at heavy applications, you might start getting bigger problems. And to answer your question, I grew up on a farm in South Africa, and my father had the same thing. You will have lots of greases there, and some of them are ancient. I think his father might have bought some of them, and he would still use them. But when he wants to do bearings or heavy loads, then he will buy new grease to do that. So that will be the advice. But for normal bolt, whatever it's fine to use. It's not a problem. But changes they can definitely. If you want to be more scientific, it would be interesting to take that to a lab and say test it and see what you find.
You could got some.
And then look you up and say this is Is there any questions on there?
No,
First question.
I've been checking it. We've got nobody from asking any questions.
Well done, it's Lee.
Well, I hope it wasn't a slippery slide down and everybody's sleeping.
Rodney was trying to ask a question.
I'm going back 30 years when I was a maintenance assistant. Relatively recent, yeah. And on Brunel's Railway, of course, we have very flat curves. I'm sure you know this. And so we didn't have any rail lubricators. You had to go down to Berks and Hansworth if you got rail lubricators. But we did have, I remember, 2 or 3 up at Paddington, where there were the outside platforms, as we call them, 14, 15, were sharper curves. So when we came to rebuild the layout, which Mike was in charge of, the rail lubricators that were there were taken off, and it came to the question of where do we put them back? And I don't know exactly what happened now, but the area manager, operations manager here, said, I don't like the idea of rail lubricators on the entrance to Paddington Station. What happens if the train slips into the buffer stops? They weren't roaring buffer stops in those days. So, to the best of my knowledge, they never put rail lubricators back there. But from what you said, I thought I heard mention of a lubricator which would actually act as a resistance to motion.
Yes, top of rail friction modifiers.
Yeah.
So you have two different products that you use on the rail. The one is for the gauge phase, which is you want to reduce the friction between the two surfaces, the wheel flange and then the rail. And the other one is the top of rail friction modifier, which you put on top of the rail. So that actually reduces the friction, but not to such level that you'll have slippages. So your friction coefficient of friction is between 0.3 and 0.4. Whereas with a dry rail, I think it's 0.7, and then with a gauge phase, you want it as close as possible to 0. So your question is, if you put it on the wrong place, or to answer some of what you said is, if you put your lubricator on the wrong place, or you apply too much, and you put a gauge phase lubricant on top of the rail, you can cause slippages or slides. And that can be horrible. And the same with even your top of rail friction modifiers. If you have a top of rail friction modifier, depending on what the base of the product is, and then it depends on how much you're putting onto it, you might have to need to put a little bit on to get the effect that you want, but too much can also cause slippage.
As Mike remembers, my recollection is we didn't know about that complexity 30 years ago.
It's still using talent, wasn't it?
And I will not answer that question further because I think that's not something to it.
Do you know what sort of quantities Network Rail use in rail lubrication? And where are you involved? Is there like say an annual a request for a contractor to provide, or are you?
I would prefer not to say.
Sorry?
I would prefer not to say.
Oh, okay. Right.
But it is, they use quite a amount.
A lot, yeah. Yeah. Okay.
Okay, are we done? Okay, excellent, Frans. Thank you very much
Thank you
indeed.
very much.
Who knew?
The next reason, no reason, no reason.
And I have to hold my hand up. I was the one that made the flippant comment about just greasing the end of the bolts or just anything that happens to be available. Promptly got told off that actually, if you
No,
want.
no. You're not the first guy, and you're not the last guy that's going to say that. That'll come forward.
You're going down a slippery slope.
Yeah. Okay. I just called on me to ask Mark Howells to do the vote of thanks.
So, Fran, thank you very much for an enlightening presentation. And Jeremy said, I never knew so much went into putting something like that into the structure. So, excellent examples, good tactile stuff in the room is really useful to understand what it is we're dealing with. And it's just down to me to really say thank you again. More about the system as well. So we always forget, we always get our own discipline. We always look at traffic, we always look at drainage, we always look at bridges. But actually, this is just another part of the system. So a good reminder that we need to think more in the systems that way. So thank you very much. Yeah. And if you'll join,
Okay, that just leaves me to call on Richard for the next meeting, please.
Yes, next meeting is our president, Stephen Bell, is coming to make sure we're a good section. I'm not quite sure what he's going to address us upon, but no doubt he'll mention the PWI goals for the next. There are 7 goals, which are all detailed in the journal that you'll have received recently. And I'll do a write-up for that for news lines in the same way that I got to mention that we got news lines from last month. Hope everybody was happy with those, and there'll be a write-up for our news lines for next month about your talk. Yes, I hope I get every detail correct. I'm sure I will. So that's the next meeting next month on Wednesday, the 6th of March, the President's visit.
Okay, thank you. That just leads me to say thank you to all those who joined in from home. Thank you for your participation, and thank you to everyone in the room for making the effort to come along this evening. So thank you very much.
Thank you very much.
Look forward to seeing you at the next meeting. Thanks very much.
Thank you. Thank you.
Okay. Are you all right to get out? Are you all right to get out?
It was the way out.
Yeah. Malcolm, always make sure you